Dear students, welcome back. Let us begin the second part of the lesson in which you will learn about the comparison of T and F test. The purpose and interpretation of one-way ANOVA and T test are the same. Recall that the T test is used to compare two continuous variables in terms of its mean. ANOVA is closely related to T test. Applying ANOVA to two sample problem leads to exactly the same results as T test. Let us understand what is the relationship between T test and F test in terms of the test statistic. So, the relationship between T test and F test is F is equal to T square. Let us check the relationship using an example. So, let us perform the T test for comparing two groups. So, in the case scenario whatever we are discussing that has three groups. Now, we will restrict to two groups because we are going to show that the T test is similar to one-way ANOVA when the number of group is 2. So, let us perform the T test for comparing the groups storytelling audio and musical audio group. So, independent T test, the test statistics will be T is equal to x bar minus y bar divided by square root of the standard error of the difference x bar minus y bar. So, here x bar is nothing but the mean of the first group, y bar is nothing but the mean of the second group, and SP square is nothing but the weighted average of the sample variance of first group and second group respectively, that is represented by the formula n1 minus 1 into s1 square plus s2 minus 1 into s2 square divided by n1 plus n2 minus 2. So, this we call it as a pooled sample variance. Now, let us go back to the data set where we have two groups. First group is SA storytelling audio, next is a musical audio. So, just let us recollect these are the observation. Now, using this data we are compute all the ingredients of the T statistics, that is x bar let us take the mean of the storytelling group, and y bar we can take it as a mean of the musical audio group, and S1 square is nothing but the sample variance of the first group, S2 square is the sample variance of the second group, and based on S1 and S2 we will compute SP square and then we will compute the T statistic. So, I have given or I have expanded the formula for sample variance for the first group and the sample variance for the second group. Based upon these formula, we will calculate what is y1 bar, y2 bar and s1 square and s2 square. So, based on this we will compute SP square, so which is nothing but 115.55. So, the test statistic value will be, so y1 bar minus y2 bar is nothing but minus 18.8 divided by the pooled variance is 115.55 into 1 by 5 is the size of the first group, again 1 by 5 is the size of the second group. So, this will give you minus 2.7653. So, when you square the T test value you will get 7.647. Let us try to establish the relationship between T test and F test using the Roscoe formula. Let us compute the within sum of squares using Roscoe formula, and this is the formula, this is the data, and we are going to substitute the ingredients. The first term is the sum of squares of all the observation, that is 14058. The second term is nothing but, since we have only two group, we are going to take the sum of the first group 128 and we are going to take the sum of the second group 222 and we are going to square them and divide by the size of the group. So, the total within sum of squares what you will get is 924.4. Similarly, we will compute the between sum of squares using the Roscoe formula. The data is here and the formula is here, where G is the grand total of all the observation, N is the total sample size, and after substituting all the sums in the formula we will get the between sum of squares as 883.6. Now, we will calculate the total sum of squares using the simplified formula. So, first term is squares of sum of all the observation minus total of all the observation square divided by n. So, already we have very well know the squares of sum of all the observation is 14058 minus the grand total of all the observation 350. You have to square this sum and divide it by the total number of observation because we had only two group. So, 5 plus 5 we will get 10. So, altogether we will end up with the 11808 as total sum of squares. With all of this calculation, we have framed the ANOVA table, we have filled out the ANOVA table. So, when the degrees of freedom here is 1, because we had only 2 groups to compare. So, 2 minus 1 is 1, the totally we had 10 observations. So, the total degrees of freedom is 10 minus 1, 9. By subtracting 1 from 9, we will get the within degrees of freedom for error. And then we will compute the mean sum of squares by dividing the sum of squares for treatment divided by 1, we will get 883.6, and we will divide within sum of squares by the corresponding degrees of freedom, and we will get 115.55. By taking the ratio of these variances, we will get 7.647, which is equivalent to the square of our t test statistic 7.647. Thus, we have established the result. In this video, we have made a comparison between T and F test. We have also understood the relationship between T and F statistic. We have also established the relationship through numerical example. We will continue in the next video. Thank you.